Welcome back, folks. It's time to learn some more Python with Jordan and Jackie. But once again, this is Ain't No Jackie Here Today day, so you just got me. And today, I want to talk about what I think is a very important topic, the responsible use of ChatGPT in programming. Now, would you believe that these three images are all generated by DALL-E? It's getting really good, this modern version. I pay for the premium version, so yeah, wow. So there's a lot of talk these days about AI, specifically large language models, specifically ChatGPT, because that is, I think, like the Google of large language models in that it's the one that most people use, it's got most market share, and so on. Some people think it's, needs to be banned and avoided. Some people think it's brilliant and should be embraced. I think it is brilliant and it should be embraced cautiously. What I'm hoping to illustrate with these three slightly silly images is that whenever a revolutionary new technology, especially sort of a digital technology, comes out, pretty similar things get said, right? I'm sure there was a day when computers first came out and everyone was like, oh, computers are going to make people stupid, they're going to make us lazy, blah, blah, blah. Then the internet came out and, within some years of that, we got really good search engines like Google. There was, I think, already then a lot of concern about Google's going to make people stupid. And I suppose really what I mean by that in our context is there were concerns around the internet being used, search engines, the internet being used for academic malpractice, students will just Google their essay. They'll just Google the answer to their assignments. They won't learn anything. And that did happen. That still does happen. Unfortunately, in every university around the world, every year, there are students who get pulled in for academic malpractice because they plagiarize their essay from websites or from a book or from, a published paper. The fact of the matter is plagiarism is plagiarism. You don't strictly need the internet to plagiarize. Back in the old days, you could probably get away with it more easily. You could go to the library and you could get a physical book out and you could make photocopies of the bits you wanted, and then you could type the exact same words in with your typewriter. And the chances of getting caught for it in those days were pretty low because your professor would need to be suspicious, know that, think that that was plagiarized. Then they would need to physically find the original source to confirm that it was. These days, for conventional plagiarism, we have things like Turnitin that will compare submitted text to, known text out there and flag excessive similarity, and students get done for that, now and again. With ChatGPT style AI, things admittedly do get a little bit more complicated, right? If I, as a teacher, set an assignment to, write a 2,000-word essay about, whether potatoes are better than carrots, like whatever. I could very easily go to ChatGPT and I could say, hey, write me a 1,000-word, 2,000-word, whatever essay about potatoes and carrots. And it would do an okay job. And probably over, within a year, it's going to do a significantly better job. In my experience, when it comes to getting AI to write that sort of thing, you always get very good writing. The actual, the quality of the English, or, if you ask it to do it in Dutch, it can do that as well, tends to be quite good. Often a bit too, fancy and flowery, but I found that you can get it to tone that down by just telling it to tone that down. Generally, it's grammatically very correct. Typically, it uses appropriate terminology. That said, at the moment at least, I find that when you read it, you get to the end of the page and you're like, yeah, that was very well written, but what exactly was it saying? Yeah, I don't know. I find that, I think in general, at the moment at least, if you were to get AI to write you an essay as an assignment, and assuming the person doing the marking was, paying attention, and let's assume they didn't, that they didn't suspect it was AI generated, or they just recognized that there's no real way to prove it, and so whatever. I think often you would end up getting a pretty medium mark for the essay because in terms of the actual sort of the substance, the insight and stuff like that, in my experience, it doesn't do a fantastic job. But yes, that is a concern. I mean, thankfully, I teach technical courses where I don't ask for essays because I don't want to mark them. Many students don't want to write them. It's just not the right way to assess the types of subject I teach. So it's easy for me, relatively speaking, because I'm not trying to set that type of assignment. I think in general, we as educators need to just stop setting the sorts of assignments where you can delegate it to ChatGPT, not engage your brain, and still do well on it. And of course, exams are one of the key solutions. Just put students in a room where they don't have access to ChatGPT or Google. And if you really feel the need to assess retained knowledge and ability to write an argument from scratch, that is one good way to do it. Otherwise, it can be addressed by changing the way we mark, changing the rubric, changing the things we look for. But basically, I think trying to stop people, including students, from using AI now would be like trying to stop people and students from using Google 15 years ago. It's stupid. It's never going to happen. It's impossible. And it's counterproductive because, I mean, we need to embrace new technologies and find the right ways to use them so that we get the best out of both the technology and the person using the technology. So, yeah, that's a long intro to my overall sort of philosophy on AI. In the context of any education involving programming, I think if used correctly, large language model AIs like ChatGPT or the versions of those things that are built into programming IDEs. So personally, my main AI journey has been with ChatGPT. Just use the one that everybody uses. But I've heard good things about, for example, what's it called? GitHub Copilot, which is specifically for programming. Yeah, I have found it to be really helpful. And I am going to encourage its use in any courses I teach that involve programming. Because I think if you use it the right way, it can help rather than hinder your learning. And boy, does it improve efficiency, especially for those of us, myself included, for whom programming is a relatively small part of our lives, rather than someone who is employed as a professional programmer. For them, probably the Copilot type things, the AI specifically aimed at programming is probably still a brilliant asset. So just very briefly, my, these thoughts have been percolating in the back of my brain for a while, but then I just sat down and wrote the slide in 5 minutes, so maybe I've missed some things. But my take on the main risks and benefits of AI in the context of teaching and learning of programming are here. So the main risks. Firstly, it makes quite a lot of mistakes. So whatever you do, don't assume that it's right. If the code it gives you doesn't work, that's probably because it's wrong. If you look at it and you go, yeah, I really don't think so, that's probably because it's wrong. I have found that when it does make mistakes, saying, I think you made a mistake there, do you want to think harder, often solves the problem, but not always. So you do need to still think about it yourself. Definitely, if we rely on it too much as people learning programming, then of course it can reduce our learning. If you just blindly use it, then you won't learn anything. Maybe you'll get the grades for the assignment, maybe you won't, depending on how the assignment was crafted. But if used excessively and inappropriately, you could completely undermine your own education. And well, what's the point of that, right? I mean, if everything you're doing can be done by AI, then that's a bad line of work to get into because it's going to get done by AI instead of you because you don't have to pay AI nearly as much. And I do also a little bit worry about, will it always be available? I mean, this is probably a stupid concern. I mean, will Google always be available? I mean, maybe not, but probably. It is certainly true that OpenAI may not always offer a free type of access to ChatGPT and its other things. Maybe not, I don't know. But yeah, so, we as a society must try to be careful that we don't forget how to do everything ourselves, because maybe one day things will change. I mean, one of the big problems with these types of AI is they are very thirsty for electricity and energy, and they're not fantastic from a sustainability point of view. Okay, now main benefits are multiple, and I hope to illustrate some of those with examples today. So, commenting of code is one of those things that every programmer knows they should do, and every programmer who doesn't have a boss telling them they have to probably doesn't do it, at least not well. Commenting is where you just write little, you've seen them in any example I've given you, where you use some sort of symbol. In Python, it's a hash, to say that the words that come next are not part of the program, they're just for the human that's reading. And it helps you remember what your program does. It helps someone else who reads your program understand what your program does. And I have found that GPT does a really good job of adding comments to an existing program that you've already written. It also does a pretty good job of explaining what a program does, how it works. In my experience, it is better if you ask for just how does a fairly small section of a program work, what does it do, but it can also do quite a good job on the whole program. It is by far the best way to look up syntax, right? Anybody who only programs now and then is never going to remember all of the functions available in the language that you use, all of the syntaxes for doing weird things, the input arguments that this function takes, the format that everything should have. Back in the old days when I started programming, the way you found that out when you couldn't remember is by looking through a physical book that was like the official language reference for that language. Then a little bit later, you did exactly the same thing, but with an official website and I mean, those are still available, and that is a great place to just go and check and make sure, the official Python documentation. But it is quite hot. It's quite dense. It requires a, reasonable amount of skill to understand. What many of us have done for a long time is Google forums and example code and stuff like that. And basically all of those forum posts and example code and all of that went into the training data for GPT. And basically, I think it's just like mega Google when it comes to just looking up bits of information. And that goes for other things as well, What is the Young's modulus of mild steel? It'll tell you, but it could be lying. It could be wrong. And so in any case where it really matters, you need to double check with a more reliable source. Anyway, it's a great way to look up syntax because when you're programming, if it does lie to you, if it does give you a bad answer, well, when you put that code into your program, it doesn't work and you find out that it was wrong and then you get to the bottom of it and you fix it. So with the sorts of stuff that we tend to do programming, it's not mission critical. I mean, maybe it'll stop your program from running, but then you fix it. It is also, I think, a great way to sort of get templates, Please give me a template for, what a general class looks like in Python. Brilliant for that. Great for examples, all of that. And in my own experience writing sort of slightly higher performance code for running sort of scientific simulations and stuff, I found that it's really good, especially for a not particularly expert programmer like myself. It's really good for, the word is refactoring, but helping me change the way my code achieves what it's achieving in order to improve computational efficiency and make things run faster. Okay, so that is it for the PowerPointy type stuff. Now let's bring up that and let's bring up that. Okay, so today I'm using on the left here, a Python IDE that I quite like. None of the videos I've recorded so far with Jackie have used this one. I think at some point we will make a video about it in itself, how it works. It is called Spider. For anyone like me who has used like MATLAB and things like that for graphing and scientific computation and programming altogether, Spider seems a pretty good IDE for that. Anyway, I don't want to focus on that too much. The pane on the left here is where the code is. Here at the bottom here is the console where any like text output and stuff comes out. And excuse me. And one of the cool things for me that it has is it has a plot window as well. So what I have here is a program that I wrote while I was developing the group assignment brief for the 2023-4 year of product engineering, where you have to make a cleaning robot that's going to drive a pattern on the floor. And at first, I ultimately toned down the assignment quite a lot, but at first I was thinking, I want to get students to make the robot drive a spiral. You can't see it, which here it is. drive a spiral where the gap between the spiral lines remains constant as it goes around. And I started trying to think about how do you control the speeds of the two motors to achieve this. And I was like, wow, that's pretty difficult. And I was quite proud of myself for, in fact, without cheating with AI, I got my rusty old maths knowledge out of my brain, and I eventually managed to figure it out. Anyway, basically what we have on the left here is a program that is, I mean, it's not longer than anything that you might have written, but it's maybe a little bit more advanced, more complex in the sense that it's doing some moderately heavy mathsy stuff in order to basically figure out the position of the center of mass of a robot that is controlled by two drive wheels that can drive at different speeds, where the speed of the two wheels makes its center of mass move, but also makes it rotate around its center of mass. And this was me trying to figure out what do I need to do to the two wheels to get it to drive a spiral like this. Anyway, I thought this would be a good example to use for the showing some of the things that you can do with AI. Now, note that I do pay the $25 or whatever, 25 euros a month for premium OpenAI access. For me, I think it's worth it. But I'm intentionally using the 3.5 model here, which is the one that you get for free. It does have a big advantage in that it is significantly faster in replying to you than the 4.0. But it is a bit less clever and a little bit less up to date. But in my experience, when it comes to this programming kind of stuff that I want to use it for, from what I can tell, it's just as good. Because I think this is the sort of thing, coding is the sort of thing that AI, large language models, do quite well. Comes quite naturally to them. Anyway, so some of you might pay for the premium, some of you might not, but I figured I'd do this using the free version. Okay, so commenting code and explaining code, which I suppose in a way go hand in hand, because in order to write comments for code, you need to understand the code. So here I have a completely uncommented program that uses some libraries that I'm sure you've not encountered before, and does some pretty complex mathsy type stuff with variables with vaguely informative but not super informative names. So, you know, if I gave you this and said, hey, what does this program do? I would not blame you at all for saying, I have no bloody idea. So let us start. I'm going to go not in the order I listed things here, actually. So let's start with the ask it to explain. So I'm going to copy all of that. I'm going to go across here, and who knows, maybe I do some things really in a silly way with AI. One thing I just can't, I find it very hard to not say please, you know, because I was brought up to say please, and I mean, it doesn't care, has no feelings. But so I still find myself often wasting time saying, hey, please do this for me. Anyway, so please explain what the following Python program does. And then you probably already know, but I found that if you want to go to a new line, you have to press Shift and Enter, and then I paste in the code. Okay, let's see how this goes. Right, this would have taken a lot longer with the 4.0 version, right? So it's a pretty thorough answer. So it says, this program simulates the movement of a two-wheeled robot with differential drive kinematics, correct, and plots its trajectory, correct. Step-by-step explanation of what the code does. I mean, I won't read through all of this, but it's telling me what the libraries do. It seems to have a pretty good idea of what all the constants and parameters do. The things I'm calculating, creating the arrays that I'm creating to store the data over time in. Yeah, so that looks like a pretty good sort of algorithm level explanation. Now, let's see what happens if I please add detailed comments to the code I just gave you. Cool. Now, it has this nice sort of I don't know, thing where when you ask it to write you code, it opens this little window that is sort of like a code editor. And significantly, it does the sort of coloring of keywords and stuff. I mean, not identically to any of the specific IDEs that I've used, because all IDEs have a different, but you know, so here it uses blue for import statements and red for numbers and stuff like that. So this is going to contain quite similar information to this explanation over here, but like what I could do is just copy this and paste it back into my, well, why don't I do that? And this will be a good opportunity also to see if it actually still works. Because I have found once or twice that while it's adding comments or something to code, it messes up the code. So let's paste the new version in and let's just quickly run it to see if it still works. Chat, you dork. Yep, so it's messed something up. This variable S1 is undefined. Okay, so I don't want to, so now I would need to go through and figure this out. So what I'm actually just going to do is undo. Yeah, so classic example of ChatGPT being a slight moron. So my two options there would be to either go through the new version and just, I'm sure it's just made some small little syntaxy bug, typo type thing somewhere, or I could just extract the comments. I mean, that would be a bit laborious, but I could just go and like extract the comments and put them in. But in any case, we see here that it's saying what all my libraries are doing. It's added comments saying what the parameters do, what sort of sections do. It correctly identifies that this here is the main loop that runs the simulation that goes through time and updates the equations. It's identified correctly. And so I think it was probably helped a bit by the fact that I used somewhat logical variable names. So, I used COM for the center of mass of the robot. I mean, doing that is good practice anyway. You should definitely, as much as possible, use logical variable names. But you also want them to be shortish, which is why I wrote COM, not center of mass, because I have to type it over and over again in the program. But yeah, so it's done a pretty great job of figuring out what all the things are for and putting in useful, informative comments and one or two mistakes along the way. Okay, so that is two of the things. All right, so let's look at something else. So I've got these libraries here that there was a time when I had never used them, didn't know what they were, and I imagine you probably don't as well. So let's ask it. Please, see, I can't not do it. I can't not say please. Cool, nice thorough answer. Okay, so this is the sort of thing that, yes, you could totally have gotten through Google searches as well, but I think this is a easier way and a slightly more digestible kind of way. So it's explaining that NumPy, which stands for numerical Python, is a Python library for numerical and scientific computing, not something one needs to do within the product engineering bachelor course, but maybe in master's or something. So it does a pretty great job here of explaining the key functionalities, the sorts of things it can do for you. Then it goes on to give a simple example. Cool. So now let's say, so I'm like, okay, I see here that this is kind of how you make a NumPy array by calling the array method of the NumPy library. Incidentally, this syntax here, where you import a library as something else, basically lets you import the library, or sorry, they're actually called modules in Python, and rename it. And here we're renaming it something shorter, just so we don't have to type as many characters all the time. So, okay, so that's creating a little array. So now let's say I wanted a three-dimensional array. So a 10 by 10 by 10 NumPy array and initialize all elements as 0, say. Boom. There it shows you how to do it. In my experience, it's much less likely to make errors in short things like this than it is in longer things. And so, depending on the context, I could either just see this. Okay, so if I want a 10 by 10 by 10 array of zeros, then I need to call the zeros function rather than the array function so that I'm initializing it all as zeros. And then I give the dimensions, 10 by 10 by 10. So I can work out from this that if I actually wanted just a 10 by 10 array, then I would probably just leave out that, and then I'd get a 10 by 10 array. So depending on the context, I could either just copy this code directly into, copy this line directly into my own code. Maybe I would need to change the name, or I could just understand what it's telling me and then go from there myself. Okay, come on, brain. Yeah, it's easier doing this with Jackie just because then I have someone else to, to talk to and keep me going. But yeah, okay, so that is good. Thinking examples. Okay, so I mean, if we just want to look up, yeah, all right. So you probably haven't just watched it, but I just finished recording the video about objects and classes. So a class in Python. Cool. So this has gone a little bit deeper than, yeah, this example uses more of the class functionality than I showed in my video, but it shows you the syntax for creating a class. I mean, obviously I can guess, I mean, it should be obvious that it's, because this is just an example, it's showing, it's just picked a silly name, my class. I would make this whatever class I wanted. Shows that I can have, this is not something I covered, but that I can have attributes that are class rather than instance attributes, which means that all instances of the class, all the objects created from the class would have this class variable called that contains I'm a class attribute. Here is the constructor method that is called when you create a new instance of the class. This shows me the slightly weird syntax, shows me how to get input arguments, how to store them in instance attributes, instance variables. Yeah, and then shows me how to make an instance method, which is what I did in my example, and then how to do some other things that go beyond what I have included in my course. So yeah, super helpful. Yeah. Oh, so side point, in product engineering, we do quite a lot of stuff in CircuitPython, and from what I can tell, the 3.5 version of ChatGPT doesn't have fully up-to-date information about CircuitPython because one of the libraries. Okay, let's see. Are you familiar with CircuitPython? Yep. Okay. Cool. So it is familiar with CircuitPython in general. That's great. Talks about how it's more aimed at microcontrollers and stuff like that. All right. Please make me a small circuit Python program to control a RC servo motor based on a potentiometer signal. Let's see if that works. Cool. So this looks like very much the sort of, short, simple example that you could also very easily find on the internet. But again, I just find this to be more convenient. So, imports all of the necessary libraries. Okay, interestingly, it's doing it with a library I've not used myself from Adafruit Motor importing servo. I've just done it using PWM.io. But these will both work. So let's say, so it's using a library like Pulse.io and this servo library to create the PWM output for the servo. So let's say, please change that example to use PWM.io instead. I mean, probably Pulse.io is actually a better way to do it. probably. I've just always by default done it with PWM. Yep, cool, and it does that. Yeah, all right. So, yeah, I mean, all right, I'm already up at half an hour. So, you know what? I think maybe that is enough to get you all started. Well, okay, no, let me show one more thing. So, so let's say I ask it for an example. I look at this, and what is a thing that you might look at here? And yeah, okay. So just for argument's sake, so it's saying that this equation is mapping the potentiometer value to the servo angle. Interesting. With this equation, and let's for argument's sake say I don't know what it's talking about and why it's that equation. Which I think it has probably, yeah, it hasn't said much about it. So then I can ask follow-up questions. So I can say, expand on the explanation of the mapping of the potentiometer value to the servo angle. It could probably tolerate the typo, I'd imagine, but cool. So then it does expand nicely. It explains that the analog signal coming from my potentiometer is in this range over here. It explains what the PWM signals for the servo should look like. It explains the relationship between duty cycle and pulse duration and servo angle. Yeah, I mean, that's a really thorough explanation, isn't it? So yeah, okay, I think with that, I will end this video. Maybe I should have planned it a bit better than I did, but well, time is money. So I hope you found that helpful enough. And yep, that's it for today. We will see you in the next video. Have a good one. Bye.